Hello, today we are focusing on some Calculus 1 fundamentals. Specifically, we're going to look at inverse functions and their applications. An inverse function can be defined as an antifunction. That is, the inverse function reverses or undoes another function. To further break down this definition, take a look at the schematic here. Think of these purple cubes as little conversion machines. One machine is called f of x and the other is called f to the negative 1 of x. As the pears go through the machine named f of x, they turn into apples. Then when the apples go through the machine named f to the negative 1 of x, or the inverse of f of x, then they turn back into the pears. So essentially, when you are trying to find the inverse of a domain, you will look for something that will reverse the answer to the original function. It is important to note that not all functions have inverse functions. We identify the inverse functions algebraically in the following examples. Example 1 here shows f of x equals 6 minus x. If we want to determine whether this function has an inverse, the variables will switch places. To do that, the first step would be to first replace the function expression with a y. Then we would want the x's and y's switched with the equation as seen. Now, the expression reads x equals 6 minus y. Next, we want to solve for y, so we would move the y to the left side and the x to the right side, to then have an expression that reads y equals 6 minus x. Now, we know that the inverse of x is 6 minus x, so when we solve for the inverse, we plug in 6 minus x everywhere we see an x, as seen here. We end up with 6 minus parentheses 6 minus x close parentheses equals x. And once appropriate distribution and simplification has been applied, we see that x equals x, which is a requirement to determine that an inverse exists. Therefore, the expression in example 1 has an inverse function. Now, example 2 looks a bit more complicated, but we can tackle it together. Here, we see that g of x, or y, equals 5th root of 3x minus 12. We will have the x's and y's switch positions so that the equation now looks like x equals 5th root of 3y minus 12. Now, we solve for y by taking both sides by the exponential of 5. This leaves us with x to the 5th plus 12 equals 3y. Now, we will divide by 3 in order to isolate the y. The inverse function is therefore x to the 5th plus 12 divided by 3. Now, when we apply the inverse into the function, plugging it anywhere we can see an x. Here, we see that 3 can be canceled out, which leads it to be x equals 5th root parentheses x to the 5 plus 12 close parentheses minus 12. We can see that the 12s can be canceled out as well, leaving us with just x equals 5th root x to the 5. When the 5th root and the exponent are canceled out, we see that x equals x, meaning that this example 2 also has an inverse function.